Okay, right. So this is the data set we've chosen, Imet 2020. And I have already downloaded this. So I'll zip over to Google Cloud Platform. To be honest, all the cloud platforms are all much of a likeness. If you're using the professional ones, the advantage to Google Cloud Platform is that if you're not wanting to pay any dollar, you can get a $300 starting credit. So you give them your credit card details and they give you a fictional $300 to start you off. Just the small active speaker one. Okay. If we look over here, you can see that I've created a fast AI instance. It doesn't really matter what zone you put it on. The important thing is that to give it a reasonable bit of grunt, in1 standard 8 is probably about the minimum you want to go to. So that gives it 8 virtual CPUs and 30 gigabyte of memory. The GPU is not as clear cut. You've got quite a few options. The best bang for your buck at the moment is a Tesla P100. If you look over here, it breaks down what the differences between them are and what the cost levels are. So the reason why I consider the P100 to be better is it's obviously not a V100, that's the Volta range ones. So they're like the super fancy ones. But what you do get is you get the same number of gigabytes of main memory on the GPU. And the main memory is that's the restricting, like the limiter for how big a batch size you can get. And obviously, as you start dealing with higher resolution images, your batches get, your batch actually starts generating quite a lot of data. And if you're using the larger models, they've got quite a lot of parameters that need to be stored in memory as well. So having that extra storage is worthwhile. The other one that's worth looking at is your T4. It's much cheaper, but although it's got the storage, it's just not as quick. And the old workhorse used to be the K80, so that one's definitely worth a look at if you just want to do things cheap and cheerful. And also it, but you do make a slight sacrifice on the amount of memory that you've got. If you compare that to like your the kind of graphics cards you plug into your computer to play games with, and they generally don't have anywhere near 12 gigabytes on them. All right, so that's the rationale for the choices I've made. I wish I could get this to go away. Go away. So this is what I was going to base it on, the multi-label prediction of the Planet Amazon data set. So we'll give that a go. And this is the guide that I use to get Google Cloud Platform to support running Jupyter Notebook for us. It's definitely one of the better guides out there. It gets you going. So it would take you, to be honest, it takes about, I would have said about 20-30 minutes to get one of these VMs set up, which isn't particularly, it's not a huge chore. All right, so the other bits that you need to cover are, so you've got your VM that you've created. You also need to, actually, I don't know how much you're interested in creating images and things like that. Should we just kick it off and then we'll have a play with it? So I'll start that. So if you go up here in the menu, one of the other bits, need a better place to put my mouse. The other thing you need to do is adjust your firewall rules. If you remember, we did that on Light Sail as well. It's just under a different setting here. So what I've done is I've because I've been using this to do deep racer training. There's a whole host of ports, including 8888, which is what the Jupyter Notebook was set up to run on. So I've allowed ingress on that port. Okay, so we won't be able to jump into the planet's notebook at the moment because the virtual machine isn't running. If we jump back to compute engine and VM instances, you'll see it's running now. So I should be able to launch a secure shell to it. Just takes a little second to transfer the keys. There we go. That's my deep racer alias Drunken Monkey. I don't know why I picked that one. Okay, so we're on the virtual machine. And if we jump up through the history, I should have the command to start. Oh, actually, this might be worth, sorry, that's one thing that's worth probably mentioning. If we type in history, you'll be able to see some of the stuff that I was doing to move this, to actually make this work. If you're not familiar with the Kaggle API, you get a JSON file. I'll jump back to Kaggle. If you go up to here, oh, I just hide the thumbnail and my profile. So the reasons why I'm being a bit weird is a lot of the things up at the top, the Zoom actual GUI is getting in the way of the buttons I'm trying to click.
Can you not move the Zoom GUI?
I don't know. It disappears and goes up into the top. So anyway, so this is what I was trying to show you here. It's in the API, you create a new API token, and that creates a little JSON file that you can then upload to your machine. So if you create it, it drops down into your downloads folder. And then if you jump to here, the easiest way to move things up onto for GCP is you just click that sort of cog button, upload file, and then if you go to downloads, you can see the Kaggle JSON file. Once it's there, though, you do need to change its ownership and move it into your Kaggle directory, and then that allows you to do Kaggle competition download. And that happens fairly quickly given the size of the data set, but I didn't want you guys watching for 10 minutes while data downloaded. And I didn't want you watching for 20 minutes while it unzipped. Okay, so that's a quick whistle stop tour of how we got to where we are. And then if we run Jupyter, run Jupyter Notebooks, and Control V, that should kick off Jupyter Notebook. And then if we go to our lesson, we should be able to connect this. And then I guess we just start digging through the data set and seeing how to adapt it. The other option is trying to hand code everything from scratch, but that's a thankless task. Okay. Is there any questions? Well, oh, actually, sorry, I'm saying that. I bet you've been given a different IP address. You can pick your own one and get a static IP address, but I generally don't bother for these things. Quite happy for it to change each time. Okay, so it's asking for the token. So the token's over here. Have that. Paste it in there and log in. Oh. Well, that's weird. Hold on, that shouldn't have happened. Let's try that again. Am I copying and pasting the token incorrectly? If anyone spots me doing something stupid, just shout it out. You should be able to just paste that in there and click log in. Yeah, that's looking more like it. Okay, so data sets have downloaded the Imet data. So we can see here we've got labels.csv. We've got the large zip file that contained everything. We've got sample submission CSV, the train CSV, and then we've got our train and test folders. The test folders for Kaggle are the test data that they don't give you the labels for. So what you do is you train on the train data set, and then you run your model against the test data set and generate the results, which are what you then submit to the competition. If that makes any sense. So if we go back up to here and into notebooks and into DL1 and into Planet V3, should launch this time. Yeah, I was expecting this to go a bit quicker. Got a sneaking suspicion that it's probably just far too much output in some of the page, some of the cells.
Is there any reason why you're not using the Jupyter Lab instead of Jupyter Notebook?
Not any specific reason. This was just what I was using the last time. So I was trying to keep it sort of consistent.
Yeah, it's fine. Because when you were showing the different files, it might have been easier to show it on the panel of Jupyter Lab, which you should be able to just basically change from the URL that you have. If you change notebook to LA Lab,
yeah,
you should get exactly.
So instead of tree,
instead of tree, you can put lab, and you should get to exactly the same place. It's a bit slower than normal.
Yeah, that's what I'm thinking. This is incredibly slow. Hold on, let's just check the compute engines. I've not accidentally set it to be something stupid.
It might actually even be on your end because Zoom takes a lot of resources to share your screen as well.
It's a fairly decent laptop, this one.
Yeah, but also it's just like visiting a website, so it shouldn't take much of the resources on the.
Yeah, I'm just having a look to see if anything is killing it. I've got a lot of Chrome.
46 tabs open.
Yeah, that's probably not helping. I'll close my.
Oh, I think it finished loading.
I'll take a wee bit of load off of it. That should help. Yeah. Just clear workspace, I guess.
Yeah.
This is performing incredibly badly. Just gonna
Yeah,
see
sorry, I sidetracked you from what you were doing. It was just
yeah. All right, we'll ignore that for just now. Okay.
Yeah.
All right, so I'm assuming the headers will run the same. We probably want fast AI. We don't need to do the getting the data stages because I've already done that. And we don't need to do the unzipping because that's already been done. And let's try and use where our data is. So data set. We'll go to the Imet directory. Okay, so that's definitely our directory, and then we've got our train directory underneath it, and we've already unzipped. We don't need to do any of this transmission stuff. That was me trying to torrent down the data. And then if we do, so this is the train CSV that it's loading. So I'm guessing we just use the train CSV from the one that we've got instead. I'm wondering if we just delete all these bits so we've got less clutter. Should we just purge it all out of the way?
Yeah, good idea.
Yeah, so we'll leave the bit about doing the Kaggle. That's probably useful for people. And the unzipping, but you're probably not going to need any of this. Let's go. We'll cut the installation of transmission. There we go. That gets rid of a lot of the junk. So if we define our path, I guess it's going to be one of these POSIX paths, won't it? If we add one here, and so we'll have to define what path is. Oh, what's going on here? Path equals and we'll give it something like this.
What is that path object?
It's they have POSIX paths. If we go to our last collaboratory one, hopefully this is the right one. I should be able to show you the.
So is that part of the Google integration, or is that separate?
No, it's part of it's one of the fast AI.
Okay.
I actually think it's actually part of pathlib, which is standard Python.
Oh, is it?
If you do import pathlib from pathlib import path, it's a standard Python.
Oh, I thought POSIX path was part of this.
No, they have depending on which machine you are, it actually comes out as POSIX path or Windows path, but it's actually part of a standard library.
All right, that's cool.
That's really good to know. I always only use os.path, and it can be a bit clunky at times.
Yeah, no, I also started using this class much more often because it's much. You can do a .glob and look at all the stuff with regex. It's quite cool.
Cool.
Oh,
right. So we know that this is not called. Oh, I think I'm just going to close this labs thing. It definitely doesn't seem very happy.
Yeah, just close it.
Yeah. Yeah, that's a bit weird. I didn't actually do anything weird with the installation. This is just the standard Anaconda that comes with the most recent PyTorch GPU accelerated one. So I wasn't expecting it to have any issues. Okay, we don't need to do. So we've got our path, and if we jump back to here, we can see the data sets, CVI Imet. We should be able to see what we have got. We've got our labels.csv and we've got our train.csv. So if we take train.csv, hopefully this will work. Oh, there we go. So we've got our attribute IDs. So these attribute IDs are the obviously numerical representations of things like pottery, ancient Greek, that sort of thing. If we look at our data set, oh, hold on. Just going to try and kill some of my tabs so that I don't bump into the header anymore. Don't need that. There we go. And we don't need this. That'll make it a bit simpler. Okay, so we jump back, we'll have a quick look at the Kaggle data set. So we've got sample labels. So the labels is probably going to be our the attributes and what they actually apply to. Yeah, there we go. So we've got the numeric converted into the actual values. But to be honest, for our purposes, we're probably okay just using the attribute IDs. Although it would look a lot nicer if we managed to get the labels coming out correctly. Okay, so in this one, I'm thinking probably the transformations should be okay. So what the transformations, if you remember, this is you doing your data augmentation to allow you to avoid overfitting, and also to get around having too small a data set. With this data set, actually, we're not dealing with a too small data set, but it's still worth doing for to avoid overfitting. The flipping vertical is to allow it to flip vertically. The max lighting's just changing the amount of brightness that it can play around with. And the zooming and warping is to constrain it warping an image. And these choices that you make they're sort of dependent on the data you're looking at. If you slightly warp a jug, it probably isn't going to stop it looking like a jug. If you flip a jug upside down, it's probably still going to look like a jug. But if you, I'm trying to think, a good data set would be that flipping it wouldn't make any sense on an image. Like written language. So like if you were to flip your MNIST data set back to front or create a mirror image of it, then that really wouldn't help your model at all, would it? Because like back to front writing is fundamentally different to right way round writing in any form of language. But I suppose a picture of a primary rainforest or a jug, if you flipped it backwards, it probably isn't going to make it too difficult to identify. But I wonder if maybe some of these things are going to have things like writing on them, so maybe we probably do want to stop it flipping the image. Or should we just roll the dice and see?
I think we should just roll the dice and see. I mean, even with handwriting, it can be useful to do some transformations because, you know, not everyone has the same 7, for example, when they write a 7. Some people make it more inclined. So, you know, it really depends on the transformation. Yeah.
Okay. Next one, so we're getting an image list from a CSV. If we look at R1, if we look at train.csv, it's not letting me see it. Oh, here we go. So we've got the what looks like the first fragment of the image name. So that will probably be very similar. And the folder that we're going to be looking in is the, let's see what folder did it have? It's the train folder, I guess. It should, this will put screeds info out. Yeah, there's lots in there because it's having a think. Let's not do that. ls -c, does that just give you a count? Oh, no, LSC does not give you the count. Yeah, that's what it is. So they're all got .png on the end of them. So that's good to know. So those two things tie up. So we'll use the train, and then I guess we'll swap JPEG for PNG. Okay, and then we've got split by random percentage. If remember from last time, what that's doing is it's taking 20% off to make your validation set, because we don't have a specific validation set. And that, if we go back to our MP random seed, by setting it to 42 each time, what that means is we're going to get the same random split. So showing you the pseudo randomness. And then our label delimiter, saying it's a space. So if we look at our data set, that does look like a space is the delimiter. That's pretty cool. Anyone think any more changes to this, or should we just kick it off? I like being an experimentalist. I'm just going to kick it off.
Yeah, let's go with it.
Okay, so our next decision here seems to be size. So if we remember, size is it's the shape of the square image. For a number of reasons, neural networks like having square images going into them, which I won't go into at the moment because I don't think I'd be able to adequately explain it. I still don't quite understand why that's an important thing. But the 128 is going to be a fairly low resolution image. If you look down below the pictures of the Amazon rainforest, they're fairly high definition satellite imagery. So when they get converted into 128 by 128, it's a bit grainy, but you can still sort of see what's going on. 128 is probably okay for us to start with. We can always expand it later on. If you remember, as you can train on a lower resolution image to get your initial transfer learning going on, and then after that you can then up the scale and usually lower your batch size.
What's the resolution we have again from the data set?
That's an interesting question. While that's happening, let's have a look. So let's download one of these and have a look. Well, the 150 kilobytes, so that's a fairly high resolution. Oh, download, and I'll open it, and we can do a bit of zoom in. It's fairly high resolution, but it's not, I mean, you can see a bit of granularity there. I don't know how much of that's coming across on the zoom, but it's starting to get a bit grainy with full photo zoom, which I don't know how much that is.
If you can find the file and just right click, I mean the actual downloaded file, or maybe you can see it there as well.
Oh yeah. So show in folder.
Exactly.
I'm a bit of a Windows dolt. I'm only using Windows because Zoom seems to work better on it. And then properties will probably tell us.
Oh, there it is on the right-hand side as well. 300 times 400.
Yeah, so they're not
So
crazy.
So the max we could go to is probably 300 times 300, but you want computer numbers, so powers of 2. So yeah, 128 or 256, or lower if we want to, I'd say.
So the one we're using at the moment is probably going to be okay. So should we, now that the data and the transformers are run, we should be able to show a batch. Let's see if it starts looking like artwork. This computer seems like it's struggling. Yay! There we go. These all look like bits of artwork of varying quality. You can sort of see, like this one, you can see these pictures have been sort of arbitrarily skewed a little bit. So that it looks like the transformations are working, and none of the imagery looks completely nonsensical. Yeah. Okay, ResNet 50 is what they used for the Amazon. Should we go with the same again? Or go with a slightly smaller model? I think the reason why they're probably gone for 50 is the number of parameters that you need to be able to do multi-labeling. I think is a more challenging request to make of the model, so that's maybe why he's decided to go for slightly higher parameters.
To be honest, I'm a big fan of trying the simplest thing first to just set a baseline for yourself.
Just copy what he's done.
Yeah, or probably go even lower just to sort of try and get something that trains quick, gives you some quick results, and you can quickly establish a floor of how your predictions are going to, how good they're going to be.
Cool. So we go for the same architecture, just a smaller one.
Yeah, exactly.
Okay, so I think we'll keep all his scores. That seems to work fine. Does everyone remember what LR find does?
Shall we just
Vaguely.
Yeah. Okay. Well, what LR find's doing is it's running. It's a bit like H2O AI does, in that it's doing a lot of exploratory hyperparameter tuning. So it's the main hyperparameter that we adjust is our learning rate. Obviously, a too aggressive learning rate means that we might not converge, or a too small a learning rate might mean that our model spends far too long training. So what this is doing is it's exploring the different training scenarios from large to small, and then working out what the different loss rates are going to be. So if we then plot it, we can see that this is actually one of the most easy to interpret versions of these. If you remember, what we're supposed to be looking for is the point of the steepest descent. So you can see here that the 1 to the e to the minus 3 is pretty much at the top, and then 1 is the final one. So I figure the learning rate that he's picked probably might be a little bit too aggressive. So that's 1 to the e to that's 1 to the e to minus 2, isn't it? So that'll be there. Yeah, so I think we've ended up with almost the same graph. So we'll see if it fits. Hopefully this doesn't take too long. Because this is going to be boring to watch if it's going to take 12 minutes to run an epoch. Saying that though, we're doing a lot quicker than last time. I think by 43 minutes in, I don't think we've got the data set loaded the last time. Let's see what's happening. Yeah, I think this is going to take in the region of 12 minutes an epoch. It's definitely worth throwing a bit more grunt at it. So let's see how it's getting on. So I'm just having a look here to see if we have bought to fancy a server for the day. Okay. So we're not stressing the memory because we've still got a good percentage of it free. So we could have probably gone for a slightly lower amount of memory. But the memory is incredibly cheap, and it's very hard to get the kind of machines that will allow you to attach GPUs to without going for a reasonable bit of welly in terms of CPU and memory. And the CPU percentages are sitting nice and low. It's only using about a third of the CPU capacity. And I think we can probably do the NVIDIA to see how heavily trying to think how you do, is NVIDIA SMI a command? I think it is. NVIDIA SMI. So let's have a look and we'll see if we can have a look and see how heavily the GPU is getting used. I think you can just type that in. I think it gives you some useful output. So, we've probably overspec this as well. You can see here that it's only using about 1.5 thousand megabits, I think that is. So we've got out of 16. So we're only using about 10. Yeah, so we're only using 7% of the CPU. Sorry, not the CPU, the GPU memory, which is not heavily utilizing it. So we could have probably gone for a smaller one, or we could potentially increase the batch size.
So what is holding it back then? Could it be a hard drive? If like, I think some of the stuff is lazy loaded, is it?
Yeah.
So we might even see that the second epoch takes less long than the first one, if that's the case.
It's a connected solid state drive, I think. Yeah.
I think they're all SSDs now in the cloud.
Yeah, I think these ones are. Let's see. Should we have a look and see if I've done anything stupid? Size persistent. Oh, standard persistent disk. I wonder if I had swapped that to an SSD, this would have been going a bit quicker.
Yeah, but FastAI keeps the stuff in memory if it does it.
Oh, I don't know if it's going to be able to keep the Oh, mind you, it could potentially keep it in memory, but I don't think it is because for a full epoch, that's 27 gigabytes of data for this one.
Is it still after the transformation?
Oh, obviously, yeah, it won't be after the transformation, but I'm curious what we'd be able to, how they'd be able to optimize that, unless they stored the resized.
Yeah, that's where I was going with that thought, but
yeah, it's certainly. I found that with Colab, when you're loading from Google Drive, the first epoch takes like an inordinate amount of time, but then because it's cached all the data on the local drive, it does go an awful lot quicker for the second and subsequent epochs. But this is, I think what we're just seeing here is an exceptionally large amount of data. I'm trying to see if there's anything else we could have changed. Yeah. If anyone's got any ideas, throw them out. We can try and debug why this isn't going as fast as we'd like. Part of me thinks, though, this just genuinely might be a very large and complicated problem with an awful lot of data to churn through. And I think we have to remember as well that in 6 minutes, we have churned through over half of the available data. So that's what, 80% of, how many is in this? Does it say how many images? It's quite a lot. Yeah, for some reason it's not telling us. I suppose they're just assuming we could count it. So Control-C wrote and do that. ls back to word count. Can anyone remember what how you do? So let's do ls. I'm thinking like man ls. Get it to tell us. I think we should be able to tell what the count is. Actually, that's a bit silly. Isn't our normal way just to Stack Overflow it?
I think this ls word count is actually fine because ls gives you an entry per a row per file, right? And word count gives you the first number should be the number of rows. So if I'm not mistaken, it should just be the 140,000 that we're seeing there.
Yeah, I think it's because there's doing free rows. Yeah, so that's it. The first one. So
Yeah.
there's 142,000 images to troll through.
Yeah, it's a high number anyway.
Could it be the data read? The data read is slow. Like instead of using from DF, we are using from CSV. So that could be creating issue. The batches are read from the CSV file.
Yeah, we'll definitely see well, that should have taken us our time during our building of our data bunch.
But it happens in runtime, right? It doesn't create data bunch in stores time. So it happens in runtime. I think it's reading from CSV, therefore creation of those data bunches taking time.
But is it not all in memory?
Because we usually do a read from _df, which is I think faster than that. That's my guess.
I mean, if it's reading it all in RAM, it's as fast as we could probably get, as long as it's not reading from disk.
Yeah. The only thing I could think that we could have sped this up is potentially swap into an SSD. But to do that just now, I don't think there's any way you can just hot swap them.
That would be really clever. take out a running disk and put it onto another one.
Well, I was thinking of cloning the disk and then spawning another
Yeah.
another VM, and we could have a race.
I guess another thing you could look at is the throughput.
Yeah,
So
well,
for the
this is fun. Let's so what are you thinking from Google Cloud Platform to
Yeah.
get the throughput?
I mean, I know in AWS you can pay for the throughput,
Mm-hmm.
but there's lots of different types of throughput. There's the network, there's the disk. Yeah, I just think it's just a very complicated problem.
Yeah, I've got to admit that if I was just this is the thing, if I was just doing this myself, I would have clicked that button and then gone and made my dinner. It's one of the things I did find when I went away from doing the sort of toy problems and started doing the proper Kaggle data sets, like the cancer finders and skin lesion data sets and things like that I was playing with this time last year. That's one of the things I did notice very quickly, is that you just couldn't do it on the completely free things like Collaboratory, and even the Kaggle's VMs just didn't seem up to the challenge. And that's where it was worth paying a couple of dollars an hour for AWS spot instances, or using the equivalent preemptible ones on Google. But I found the preemptible ones aren't worth doing anymore on Google, because there's just too many people using it, and I think the preemptibles are also getting cannibalized by the Collaboratory as well. So because there's so many people using it, you're genuinely not getting much joy out of them. You're getting preempted constantly. Just isn't any fun. At least with the spot instances, you can bid a little bit higher. But as I said, though, there's hundreds and hundreds of other companies like DigitalOcean. If you're doing this regularly, paying for and leasing a server is probably worthwhile, and DigitalOcean does them fairly cheaply. I wouldn't recommend using like Lightsail, because even though they are elastic compute, you can't attach a GPU to it, and the CPUs are throttled. So it's basically like an expected usage pattern. They give you actually some that is quite good for the kind of stuff we're using it for, like inference engines, but where they're getting sporadic load. Because if you haven't been heavily using the host, it gives you like surge credit. So like when you are heavily using it, it will go beyond the CPU throttling that you paid for. But if you are regularly hammering a machine, like doing training like we are, it genuinely that just doesn't work on that platform. This is taking a while.
Wrong progress bar.
Oh, rookie mistake. Sorry, good point. At least this one's moving. I think, yeah, this is it doing the validation. So we've gone through our first epoch then, haven't we?
Yeah.
I guess we'll see when it runs the second. I'm thinking this as well. It might have been worth us, given we're going to watch this, only picking one. As you can see, fit1 cycle's first parameter is 5 there. So what that's telling it to do is run 5 epochs.
Oh, okay.
Yeah, it's going to be 5 before. Oh, I guess we could see what happens after the first one. I think if you interrupt training in the middle of an epoch, I don't think it destroys the learner. Learner will still exist with its parameters persisted. So we should be able to kill it if let's just say if the epoch 2 doesn't accelerate dramatically, then I think just going with 1 is probably the best way forward.
Yeah.
Again, not bad. That's an hour into it, and we've taken a completely incorrect, well, not completely incorrect, we've taken a notebook that was designed to detect deforestation in the Amazon, and we're actively training it now to label museum artifacts, which is, I've got to say, I think that's kind of cool. Like I don't think a year ago, without fast AI, I would have had any chance of doing this. I wouldn't have known where to start. Has everybody had a look at the Fast AI MOOC yet and seen Jeremy's videos?
Yeah, I've been watching his course V3 video. I'm on like lesson 6.
Oh yeah, Vishal, you're rocking through it. Yeah, that is lesson 6, the one with ethics in it, isn't it?
I think I don't remember. I don't think it's after that. He was still doing. He did NLP, then tabular data, and then collaborative filtering. So I think he had to start collaborative filtering. So it's not 6 plus 5.
Yeah, the collaborative filtering is a really good one to do on sort of live demos like this, because it's just exceptionally fast.
Yeah. So I was trying to do food 101, the same ResNet model on the other food data. So like some of the things he told about looking at how we look at these learning rates and things, these are really good. It does improve your model a lot in his course. Some small things.
That's cool. And what other, has anyone else been experimenting through the week? Is any other interesting stuff getting done? First epoch's always the most exciting one. You're not expecting great results, but you know whether you're on the right track after the first pass through all your data. Yeah, so it's taken about 6 minutes to process those loss rates look insanely low.
Yeah, that's very low. That's 0.5%.
Well,
that's suspiciously low, I would say.
Yeah, that's my view on it. I don't like seeing a single epoch getting us that level of accuracy. It implies that we've done something wrong. Do we try? Well, mind you, look at the second epoch. Yeah, I think that probably is what's happened. It's it must have been slow to load the data, the first pass through. Because look at it zipping along now, like it's talking like 4 minutes an epoch.
You can check and see if any of the other resource utilization's gone up for the memory.
Yeah. Let's have a wee look. To the top, we've got memory still looking okay. Oh, CPU's maxed out now. It's 100. Yeah, we're keeping
the disk then.
Yeah, we're keeping the server a lot more busy. It must have been I/O that was holding us back then. Let's see if we're straining the GPU a bit more. So we're not using up any more of its memory, but the utility rate's still fairly low. Yeah, we probably could have got. I think this would have all run on a K80. And that's one of the takeaways, though, is if your training's running reasonably well, and you've got an awful lot of space, and it is sensible to stop your training, shut down your VM, and reconfigure it with the appropriate hardware. A lot of this stuff is fairly cheap. I mean, this server is probably burning about $2.50 an hour, but if we dropped it down to a K80 and a slightly smaller memory footprint, we could probably drop that down to like $1.50 an hour.
Yeah, and then you could possibly bring it back up by swapping to an SSD and maybe giving it some more CPU, and you're probably more effective for still less money.
Yeah, and that's the thing, is it's fine tuning is a really important skill with this. I've got to admit, this is my default one that I start with, but I'm always willing to adjust it. And you've got to also think like what you're asking it to do. When you're training, you obviously need your GPU attached, and you probably do want a decent amount of CPU capacity. But if, say, for instance, you were kicking it off to download the data, and the data was going to take like 14 hours, there's no point in you running that big beefy server. So shut it down to and reconfigure it to maybe 2 vCPUs, no GPU. That thing's going to be down to like 10 cents an hour. It's insanely cheap stuff. And then just leave it running overnight to download your data. Same thing with unzipping, unpacking the data. These kind of things that aren't easily parallelizable. Don't worry about it. Go do something different, and leave it churning away on a nice cheap VM rather than using the premium resources. But yeah, goodness, this is a substantial improvement over the first epoch. I've not seen something speed up that much since I tried doing the cancer one on the collaboratory.
That's really cool. By the way, we do pretty much the same that you were just saying with the GPUs as well, where we have our typical virtual machines, which is where we always run our Jupyter environments. But when it comes to actually training deep learning models, we do all the pre-processing that we possibly can on those machines, and then really have basically a bundle of data and some scripts to run the training all set up. Then we start a powerful machine with a big GPU, move that over, run the training, and actually with our scripts we even set the box up to finish training, and when it's done training, push the data back, shut itself down, so you can leave the office in the evening, set it off to run, and in the morning you can just go and fetch the results, and you know it only cost as much as it absolutely needed to.
Yeah, it's definitely one of the things that that burns people's wallets, is leaving these machines on, walking away doing something else, and then coming back 3 days later. Exactly. When the billing alert starts buzzing on their phone.
Exactly. That's why we include just basically a pseudo shutdown at the end of a training script.
Yeah, it's always worth as well. Remember, there's 2 outcomes. You could either have a valid training experience, and equally you could have written some shonky Python. So it's definitely worth having in your exception handling the same shutdown behavior.
Yeah, we do that as well. And typically as well, if we wrap it in a class, you can have your done.del, I think. And then that can be called even during exceptions. So you can make sure that even if your program terminates, that you still write a log and maybe a current status if you still can get a handle to it. So there's some really cool stuff that you can do. Not all of it works all the time, but yeah, it's a live and learn kind of thing.
In Python, there's the @exit library as well, which lets you register functions that will get called when your code is shutting down.
How's that library called?
It's @exit, so @exit. This is part of the standard library.
Oh, that's really cool. I've probably been basically writing that library myself, but I'll have a look. It might make things easier. Thanks.
And if you can ping that onto the chat, then that way it'll get persisted with the presentation thing that we're doing here. Cool, thanks. Yeah, I'm looking at this though, and although it's going a lot faster, and we are seeing our validation loss drop, it's just insanely accurate. I'm not convinced that we're just with. Remember what we're doing here is because we've got the frozen model, so the only weights and biases that we're modifying are the input and output layers. So we've left the vast majority of all the intermediate layers static. I think, but then this is one of the other things I was just going to point out. There's actually a third exit. If you are training, I mean, obviously there is this natural instinct to build the most accurate model you possibly can, but if your business case doesn't need that additional 0.01 of accuracy, and you can get the step before that with a tenth of the effort, you are much better off packaging that and then moving on to the next problem. Because as well, if you come back to the problem in another year's time, the state of the art moves on, and refactoring it to whatever the newest, coolest model is probably going to get you an awful lot more gain than that 0.1% accuracy was going to get you at this moment in time with a substantial amount more effort. Yeah. I think if we kill this, we can probably freeze it, and then we can start having a look and seeing if it is as smart as we think it is.
So if you kill the learner, it'll still retain the training that it's done so far.
I think it does. Yeah, so this is actually
Keras does, so I'd be surprised if Fast AI doesn't do at least the same.
That's cool.
Yeah. Should we try stopping it?
Maybe let that part finish that validation and then stop it. That's just another minute away.
It's either that or we do something else for 10 or 15 minutes. Because I'm looking at what this is doing here. This example isn't doing much to check the because this example was just to push the values into Kaggle to check how you do on the leaderboard. So he hasn't put in any of the fun validation and inspection of the results. So I don't know. Do we just do the same approach and we let Kaggle validate our results? That would be the more Kaggle-y way of doing it.
I mean, we could load a couple of the test data entries and just have a look at how they're being labeled and see if they intuitively make sense. I mean, you're not gonna be able to tell all the details, but just loading a couple of images, letting our network label it, and then see if those labels make any sense, and if they even go together, or if we get like contradictory labels on items as well.
Yeah, well, that's what I was thinking. Rather than sit watching this train, should we write the next bit of code? So we can either do the get it to start. We can either modify this bit of code here and try and get it to generate the labels for Kaggle. and then we could try doing a Kaggle submit, or we could start porting some of the like the top losses and things like that.
Yeah, I would like if we can submit in Kaggle. I want to see how much FastAI will compete with other models and other submissions.
Cool. Yeah, so I've got submit predictions, so you can either build a notebook, but I would actually maybe have been the nicer way of doing it. The reason why I was doing it in GCP, I wanted a machine that had a bit more grunt than Kaggle gives you.
What's the number one on the leaderboard right now? Because I'm interested to see if our current scores are actually ridiculous, or if it's just in line with what people have.
I'm looking at these guys. Yeah, score 0.75, so that's 75% accuracy, I believe. Which our model thinks it's substantially better than that.
Yeah, it does feel like something's gone a bit off in the
mean F-score beta. What have
we should probably just check ours with F-score as well, just rather than just the raw accuracy.
Yeah, what is our accuracy? Because it's multi-class, right? So what is it classing as accurate if all the classes are matched, or if one is correct, or how is it doing that?
Hold on, let's see what our F beta is.
So F beta.
Oh, there we go. Yeah, so the way our F beta is increasing, and 0.43 compared to the leaderboard of 0.75. That's starting to make more sense.
Looks more reasonable. So what's the accuracy thresh then that we're seeing there? What's that?
Yeah, I'm
Well
not
done,
100% sure. Shall we?
That's even gone down a bit, I think.
Okay, so the learner architecture. So we're not using ResNet 50. Measure is a little bit different. We use accuracy fresh instead of accuracy. Determine the prediction of class.
Accuracy thresh is just threshold. Accuracy with a threshold.
Oh yeah, of course, because it's multi-labeling. So it's gonna we're gonna get it's gonna come back with all the labels and giving them a percentage.
So we see like a threshold, and all the labels which cross this threshold, we count them into the accurate ones.
Mm-hmm. So I suppose the accuracy threshold for us, our ones need to be correctly labeled. They need to be 99% accurate, which is why our F beta is low. So let's see if we can get an example of what F beta means.
To be honest, I still haven't quite understood the accuracy threshold there, how that applies to the multi-labels.
All right, so it just combines precision and recall. Oh, okay. All right, so that makes sense. So it's a measure to penalize false negative errors. It's definitely one of the areas I need to expand on is understanding the different metrics that you can use and the importance of one over the other.
Yeah, F-score is generally a bit better against for safeguarding. For example, if you have a terribly imbalanced data set, then you might be able to get a raw accuracy of 90% with a block of wood. But getting a good F score will actually mean you have meaningful results.
Mm-hmm. So it's got to pick up the correct results, and it's not to misdiagnose any of the labels.
Yeah. So, for example, say, I'm just going to use our business case where we're trying to classify invoices. Now, 99% of invoices are good invoices and 1% is bad. Mm-hmm. If you run any classifier over that, you will get 99% accuracy because it just says, yeah, all invoices are good invoices. And your F score penalizes that 1% a bit as well. You're probably going to still be at 0.5 or so because it's essentially somewhere between your precision and your recall. But or higher depending, but then you can do additional things to balance that out as well, like oversampling, like weighting, etc. But it really is a very useful metric.
When I tried to explain this to my internal ML club that I run at my company, I use the analogy detecting unicorns in a field full of horses. It's pretty quick to get an accurate model.
Absolutely.
Well, given our F beta is trending in the correct direction, and we've explained our insanely good training loss and validation loss, I think that I'm going to count that as a useful 20 odd minutes that we've been watching this. So 44, so it's gone up. We're still not worrying the leaderboard though. 44. Where would that place is? Oh, actually, it would get us off the bottom. So we've got the so it'd stick us in 41st place, assuming that this generalizes onto the test set. But yeah, I definitely think it's worth. I think we should definitely try and rather than freeze it, unfreeze it and try to fine tune it further. Once we've now got a model that we think does something meaningful, I think it probably is better to try and generate the submission CSV and try and submit it to the competition. So should we go down and have a look at the code to do that? Okay, so we've got our test data set already, and it's not called test JPG. Oh, bums, I did that again. So we've got our test. We've not done anything to make the labels meaningful either, but I don't think you need to do that for the sample submission. If we cat the sample submission CSV, yeah, so it's just got it's the name, comma, without the .tiff on it, and then it is space delimited the classifications.
Yeah, so it looks exactly like the training labels that we have.
Yeah, so that's good. So we don't need to do any of the conversion into like human interpretable labels and back again. So again, unless you're going to get any use out of it, there's just not much point.
Yeah. Does Fast AI there? We did this from CSV. Does it have the opposite, just saying to CSV?
Yeah, it does.
Oh, that's just the data frame as is. Oh yeah, that of course works.
Yeah, I'm thinking this. I don't think we're going to have to make two. I don't think we're going to have to do too much. So we're going to have an image list from folder. So it's adding two of them together. They must have had two. Yeah, they must have had two folders. I don't think we need the add. Any objections to me chopping this bit off?
Nope.
No.
No, we'll just go for that. Boop. So we're going to have a different one. So we're getting predictions, and the predictions are coming out. And he's used 0.2 for the threshold. I take it the threshold that we'll be using will be, we'll be putting our F beta score in for that. That doesn't seem right, because he was getting F betas of 0.92. And over here, the threshold's been used as 0.2.
So I guess that's something for us to choose, isn't it? Because it all depends on. I don't know how we know what threshold the current model is using in terms when it's getting these F betas.
Mm-hmm.
Yeah, I think whatever it is, we should just use the same thing, so and not explicitly overwrite it.
Mm-hmm.
Gut feeling is we'd rather break something by doing that.
So leave it as it is.
No, I don't mean leave it at 0.2, but find out what the what we're using in the validation, because there we are assigning labels, right? It's not running, or is it running the validation just against the raw outputs?
It still needs a threshold though, because otherwise it couldn't assign labels. There needs to be some threshold that's using to determine if a label is assigned or not.
I think this is like where when you're doing your bounding boxes and multi-labeling an image with multiple things in it, each of the boxes is predicting something, but you only highlight to the end user the ones that have had high accuracy scores. I'm just trying to see if there's anything we can grab out of this. We've got our transforms. Right, so
there we go, threshold 0.2, yeah.
Yeah, so we're gonna have to use the same one. All right, okay, that makes sense. So we'll use 0.2 as well.
Just for consistency's sake, I would then take that just that line threshold equals 0.2, take it out of here, move it up there, and just use that everywhere. So you don't have to repeat yourself if we ever change it. What I typically do for that is treat it like a module, and even have it in caps, because then you know it's a global setting that you set at the top of the notebook, and then everywhere everywhere you reference it, you know where you can find it.
Yeah, that's cool. So we'll leave that as an exercise for later. So how's the training going along? Sorry about all the scrolling here. What, did our training finish? Nope, that's different.
Ah, there it is. Yes, it did.
Yay, that's cool. So we'll give it a save.
We had an RN34, did we?
Yeah. I'd be interested to see. We'll maybe during the week we'll try running it with 50 and see if we can get higher accuracy. Should we? I'm just looking at the time. We've only got about half an hour left. I think probably better not to try and do the fine tuning. I'm just trying to see what kind of. Yeah, they didn't really. He didn't get. It was only marginal improvements that he made from there.
Does it take much longer than the other epochs? Like, could we just run one fine-tuning epoch, or does that actually take longer than those 6 minutes?
It'll take roughly the same amount of time. You're seeing here, like his first one took about 18 when it was running. So there's a lag even when he was running it. So yeah, we'd run out of time if we tried to do the fine tuning just now.
Okay.
Okay, so we'll need to do learn.export. And then so we're getting our 26,000 and we've got test. I'm just trying to see if there's anything to change here. It doesn't look like it.
Yeah, that of course will take a while as well because it's going back to the hard drive.
Yeah, but again, it's only 26K images, so we're nowhere near as bad as what we were doing before.
Yeah,
should be about a tenth of the time. So if we can look ahead, we should be able to see. Well, I mean, in fairness, this is going fairly well. It's all running. We've not actually had any significant errors to debug here. We're getting perilously close to be able to have something that we could submit and get a ranking. Don't think we're going to be wearing the leaderboard though. This is one of the things though with Kaggle. It's a bit like a deep racer. You're worth trying and then trying again, then trying again. They don't let you just do sort of infinite numbers of submissions for very much the same reason. With Deep Racer, it's I think it's once every 30 minutes you can submit your model for evaluation. It's to stop, but I think in this case, it's more, they're more worried that there's going to be information leakage.
Yeah, I think I saw when you were on the dataset side that there they allow like 5 a day, 5 submissions, so even a bit tighter.
But it's worth. I figure it's worth submitting early just to see if you're even closely on the right track. Because obviously, if you're getting like a pretty good F-beta score, so like we're thinking we're going to come in about 40th, and it turns out that we're actually closer to 0. When Kaggle verifies it, we know that we're doing something wrong.
Yeah, yeah. If we get the same score from Kaggle that we get on our side, then we at least know that we can compare.
Mm-hmm. So that's it. Basically done all its predictions.
It doesn't take very long for the results to come back, does it?
No, it shouldn't do. I'm hoping that we'll be able to see them happen. I'm surprised this is taking so long. Although it's obviously going through all our results are going. Yeah, if we've got thousands of classes, we're going to have long lists of probabilities for each of the images, and we're now just haircutting that down to the ones with 0.2 or higher. So yeah, this is a bit of there's a little bit of processing to be done here.
No, but shouldn't be too long either.
No.
There is, by the way, an easy way to give you a progress bar on that as well.
Oh, is there?
Yeah, there's a really good library called TQDM. So if you just install that and then around your preds or whatever you loop over, if you just write TQDM around that, or tqdm.auto, I think, then it gives you a nice progress bar showing you, yeah.
Hey, yeah, I'll look at that as well.
Yeah, so you can then just do from TQDM, import TQDM and use that, or you import auto, because auto is a bit clever in detecting whether you're on a command line or in Jupyter, and it formats your progress bar nicely.
Nice. I think Elias we might need to rope him in to do a demo of take it from the hobbyist level up a notch into the professional.
Well, I am an engineer, so I've got a lot of those things, but I can't actually teach you much in the terms of the actual cool data science bits. But I can teach you probably a thing or two around that.
Yeah, well, I think that'd be a useful thing, sort of even just a 30-minute kind of thing, or here's some of the good tools, here's what they look like, here's where to get them.
Yeah, I can easily do something like that. In fact, I'm going to do something that's vaguely similar at the EuroPython as well, if anyone is joining that. It's going to be a whole online conference this time.
Oh, nice. Can you share a link in the Slack or something?
Sure thing, I'll do that.
Because I think this is it. We've all got a lot of time on our hands at the moment. Oh, this is a shame. I was hoping this would run fairly quickly. I don't think any of the remaining stuff. So hold on a second. Let's. Oh, it's head, isn't it? Just gonna see what the. So it's ID and attribute IDs. So I think what we do is we change that to. I think we change that to ID. And then, oh, hold on a second. Am I making a mistake there? Or did I just change the columns?
Those are the column names.
Yeah, no, that's correct. You're doing it right.
Cool.
In fact, this is, as it stands there, it's actually repetitive because you've got the columns defined and you've got the column names in your dictionary there. If you have this there, you can just remove that whole columns thing at the end.
All right. Okay, we can try that. And then, oh, this is actually one of the nice things about Google Cloud Platform. It's got a shared clipboard. You've noticed I've not had to do any of that right-clicking that I was having to do on Lightsail to paste as text and things like that. All right, so you reckon get rid of columns entirely, or
yeah.
change as little as possible?
Or just completely. Yeah.
Cool. Okay, and then we need to change the Kaggle competitions name.
The other thing is, did you actually have an index, the file on the left? Because that might. Yeah,
Sorry.
when we save, okay, that's fine. When we save it, we have index equal false, which is fine.
Yeah, I think it should be okay. I've spelled attribute, I copied and pasted that, so I shouldn't have got that incorrect. And if we go here, this should give us the competition's name. Oh, this by the way, this is the instructions of how I loaded. I've already posted all this stuff in Slack though. So it's how to clone the FastAI repo down, the instructions for setting up Google Cloud Platform, and this is the Google command line values to spawn the virtual machine. You should be able to just take that competition name and swap it for this competition name.
That labeling is taking way longer than it should.
Yeah, I do agree with that. Do you think it's because there's so many classifications? Because I say it's like good invoice versus bad invoice. You're only going to have 2 columns for every prediction, whereas this prediction is going to have as many labels as we've got, I think.
Yeah, but still, I mean, we have what, 6,000 predictions and 4,000 labels, and the basic operation is super fast. So 6,000 times 4,000 times I don't know, 0.01 second or so should long be gone.
No, I'm agreeing with you. I mean, well, it's 26,000 predictions we've created, and those 26,000 predictions have, is it free? What do we think? 3,500 labels.
Yeah.
3,500 times. Yeah, it's
okay. It is a sizable loop, but still,
it's like, not maximizing the CPU. Although would this be? I think this would be single-threaded, wouldn't it?
Yeah, it's maxing out 1 CPU. Okay, that might explain it.
Yeah, I don't think there's any. Actually, there probably is a smarter way of doing this, because we probably could have broken this task up across the 8 CPUs.
Yeah,
it's going through line by line. We could have broke it up into 8 chunks and run this command line.
My favorite way of doing that is with a library called pmap. I don't know if you're familiar with the map function, but essentially, instead of writing your list comparison like you have here, you define everything that you want to do as a function and then just say map your function or a lambda over preds in this case.
Mm-hmm.
And then if you have the pmap library, you just change map for pmap and it automatically runs it on as many threads as it can, collects the results in the right order and gives them back to you. It's absolutely brilliant.
Yeah, that does sound really good. So I think that's definitely another. Let's add a cell here, and we'll try and improve this through the week. So Hold on.
Does it actually run it on multiprocessing or on multi-threading?
I think there are two different implementations, one each. The one I use, I think, is based on multi-threading.
We're maxing out the CPU at the moment, though, so I'm not sure if.
Yeah, you're right, but I think there is one on multiple processes as well.
That's good to know, though. I'll need to check it out. I haven't seen it before. We also have the problem that with Python, you have the GIL that doesn't allow you to do too much.
Yeah, it actually really helps to express your things, your instructions in that a bit more of that functional way of mapping over a function, because you can get around some of the locks this way, and especially with not built-in, but with handy libraries like this pmap, you can actually make it really easily get a lot of performance out of it. But you do need to write your code a little bit different.
Sounds interesting.
But this is the thing, is
functional programming anyway, so I might be a bit biased in that direction.
But that's the thing, is it's you run the stuff, if it runs fairly fast and doesn't stress you out, leave it as is, and you get something like this that bites you a little bit, then it's worth refactoring and improving.
Yeah, absolutely.
I think this will be for any of the data sets like this where there's a large number of available labels. This is probably any of these kind of Kaggle challenges will be fairly limited in this way. All right, but I don't know how much more we want to watch this. What I can do, if you want, I can let this run, and I can come back to it and submit do the submission. Literally, it should just be executing these last 4 lines of code. So I don't think you'll really be missing much. And then what I'll do is I'll post on Slack the results, and then I'll bump this stuff into GitHub repo so that we can all see the code. And I guess throughout the week we could try and improve it.
Yeah, sounds good.
Sounds all right. There wasn't really much more I was wanting to talk about. I think we've gone through all the bits of Kaggle I was wanting to show off. The bit at the top here, where the loading of the Kaggle dataset just basically needs your key. So the Kaggle competitions download. This one was the Amazon from Space one, but if you'd substituted this piece of API code, that would have done the download for our data set. Then it's just a case of unzipping it. Really not. They've really made it kind of easy, to be honest. The biggest challenge I've found, the biggest challenge, I guess, is making sure that your submission CSV matches the guide or sample submission.
Yeah, I've seen another approach to make that part a bit easier is to actually load the sample submission and overwrite the columns that you need, and then save it back so that you're sure that you're not adding extra stuff.
Oh, that's a good idea.
I mean, for this specific case, it's probably relatively simple, so it shouldn't be too much of an issue. But
that makes a lot of sense. So I'll update the sample submission CSV rather than generate a sample submission CV.
Yeah,
CSV.
precisely.
Oh, bit sad. I thought by skipping doing the fine tuning we would have been able to done this in 2 hours, but I think we've got 95%. We're just doing pandas data frames now in calling a Kaggle API command. So we're not doing anything particularly clever now. Okay, right. Well, let's do this. Let's cancel a bit early. It's only 10 minutes early. We'll all go get our dinners, and I'll update on Slack how well we did.
Yep.
Sound good?
Cool. Yeah.
Thank you very much, as usual.
Oh, it was great. Thanks. And bear in mind, I'm learning as much from this as you guys are.
Cool. Yeah. Thanks a lot. Cheers.
Cool.
Cheers.
Right. Catch you guys.
Thank you.
Thanks.
Bye.
Right.